let's get the idea of images, range, and pre-image under functions. So I have a very nice diagram here to demonstrate that. Now suppose this is a printing machine, right? And then maybe you are here, this is your image, right? Your rare image. And then when you take a picture of your rare image, you must print that, then we get a printed image. Is that okay? So that's just a simple scenario, right? So let's say this is a printing machine that prints the image, right? They print the rare image here to get a printed one on the copy, right? Very simple. So assuming you are here, we took a picture, so we can call it mathematical. Let's say you are x, then we put it inside a function or maybe the machine. So let's say f of s, right? Let's call the machine f of s, meaning that we are putting the rare image here, into the machine to get a printed one, right? That is very simple. This is how the function sort works. Is that okay? So here we are having here the rare image is what? The pre-image before the image, right? Pre-image before. So before the image. So we call this one the pre-image, and then we call the printed one the image. And this is the machine that was doing the transformation, right? So we pick it, we put it inside a machine, then we get a printed one. Is that okay? So you have to make sure that you understand the image and the pre-image, so that when you get any question, you can be able to grab that. And this one also helps in, I think this covers almost 60-70% of the mathematics work. Okay, now let's continue with some simple questions and see how best we can understand that. So the pre-image into the machine, then we get an image. Is that okay? Pre-image into the machine, then we get an image. Sometimes it can be the other way, vice versa. But let's check that with some examples here. So I have some questions here that says that the first question says that, okay, let's check the first question before we continue. So here you go. Let's check the question from the book here. And then question number 3, right? Question number 3, they say a mapping is defined by the rule by the S map to S squared plus 4 if the domain is 0, 1, 2, 3, and then find the range. Is that okay? So you should find the range. That's the question. Question number 3 says that you should find the range. You are given the domain and what? The function. They say you should find the range. Now the first question is what are the range and what is a domain? Right? Domain here technically, or maybe in my definition, domain are the pre-images that we are going to put inside a machine before we get the printed image, right? So domain is where we are picking the pre-images. Domain is where we are picking the pre-images. Then the function is the machine, right? We are going to pick the domain, the members of the domain, the pre-images, the pictures that we are taking, and then we place that inside a machine to get a printed image. Is that okay? So now all the printed images that we get is what we call the domain, the range of the function, right? All the printed images is what we call the range, right? So that is the range. Okay, so all the domains, all the printed image after they pass through the process, the transformation, which is the machine here. So let's check that on how to solve that question. So we are given the rule to be this is just a notation, right? S map to S squared plus plus 4. Is that okay? So that's the machine. So the machine is S squared plus 4. If you don't know this notation, maybe check the playlist down below. We have a video on that whereby we explain everything to detail. Okay, so this is the machine that's going to transform the pre-image for us. So these are the pre-image, right? So those is they are pre-images. The pre-images are 0, 1, 2, 3. So we are going to print the images of these 4 guys, which are 0, 1, 2, 3, 4, through this machine. So all I have to do is that you pick them, you plug them into the machine, then you get their results, right? So let's go. When x is 0, it means that the first person is 0, your image is 0. Then we are going to place it inside a machine. The machine is x squared plus 4, right? So when the pre-image is 4, they say you should square the pre-image, right? Your pre-image, your real image, you should square out plus 4 to give us what? Your image. So when you do this calculation now, so you consider here 0 plus 4, that will give us what? 4. Is that okay? So you have to do the same thing for the rest of the 3. So when x is equal to 1, so you plug 1 into the machine, that will give you 1 squared plus 4. So here will be 1 plus 4, that will be what? 5. So the same process for the rest of the 2. We are going to get 4, 5, 8, and what? 13. Is that okay? So as I said earlier on, the range is the printed pre-images, right? So what are the printed pre-images here? You have 4, 5, 8, and what? 13, right? So those are what? The pre-images. So the pre-images is all of them giving what? The range. So look at what I have done here. So the range here is what? 4, 5, 8, and 13. That is just the definitions of the range. Is that okay? So don't let the name scare you, but rather go for the image behind the name, what exactly it means. So that is what we do on this channel. So you may consider subscribing to the channel. Okay, now let's look at the second one. The second one says that let's check that. Let's check. So question number 6, right? Question number 6. What's the question? Question number 6. Okay, here we go. Question number 6 says that the image of x in the mapping x mapped to s plus 5 is 4. So find x, right? They say the image of x in the mapping. The image of x in the mapping. So that the image of s in that mapping is what? 4. So it means that you are giving the image, right? They say you should find your pre-image. Is that okay? What have you plugged into the machine before we got that image? That is what they're asking us to find here, right? They say the image of what? X in the mapping x mapped to s plus 5 is 4. So find x. So this is the function that we are giving. So this is the machine that transforms the pre-images for us. But here you are giving the image to be 4, right? And they say you should find the pre-image. What have you plugged in before we got what? The 4, right? I know that whatever I plug in, it will give me 4, right? So look at the example. Look at what is happening here. So this is the diagram. So whatever I plug into this one, right, to give me 4 here. So here the image is 4. So and the machine is what? Is s plus 5, right? So this is the machine. They say you should find this. So I know that whatever I plug in here, when I plug in x, whatever I will plug in here, I will get 4, right? So okay. Now for that reason, we can equate. Can you see that? We can equate because I know that whatever I plug into the machine, it will give me 4, right? So here, let's say we plug in x because we don't know the value. We don't know that. Let's say we plug in this guy. So this guy, that is what the function say. They say the whatever you plug in plus 5. So you plug in x plus 5, it will give us 4. Right? So when you solve for this thing, you can see that x is equal to what? Minus 1, right? So x is equal to, so it means that we've plugged in what? Minus 1 before we get to the 5. You can check that. So when you plug in minus 1 here, sorry. So let's say we plugged in minus 1 here. So minus 1 plus 5. Can you see? This one gives me 4. Is that okay? So that is another way of finding what? The pre-images. So this is how you find the pre-images, when you are giving the image and the machine, right? You are giving your image and your machine. You want to find your real what? Image before we took the picture. Okay, now the third one. So this will be the final example. If you are enjoying the video, you may consider subscribing to the channel now, so that you don't miss any interesting videos or like this. Okay, now let's check the last question. So the last question says that okay, here you go. So they say you should find question number 5. Find the image of minus 2 under the mapping x mapped to s exponent 3 minus 2x squared plus x minus 5. They say you should find the image of that under the mapping. So here you can see that we are going to find the image. Is that okay? You are giving the pre-image and the machine. They say you should find what? The image. We are giving your real image there, and then we are giving a machine that transforms that. You say you should find your pictures, right? You should find your pictures. Is that okay? So we are going to find your picture. So here we are giving the machine and what your pre-images. They say you should find your pictures, your printed what pictures over it. So this is the machine that you are giving. You are giving this machine. Is that okay? And they say you should find the image of -2 under the machine. Right, so meaning that we are just going to pick the rare image and plug that into what the machine and get what our pictures out. Is that okay? So x is equal to -2. Let's plug that into the machine. So when you do that nicely, remember it's a negative, so don't mess up. Make sure that you put that negative into brackets. So when you do everything, just that you are going to replace the -2 in the machine or wherever you see the x, right? And then do your calculation nicely. You arrive at what x is equal to what -3. Comment down below if you have a different answer. Is that okay? Comment down below if you have a different answer. So this is how you solve the image, the pre-image, as well as the range and the functions. So if you have any problem, comment down below. We are ready to help you. Thank you for watching.